Yes. Yeah, good afternoon all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes. Yeah. So in the session, we had some discussion about this, right? What is big data? Why Hadoop and PySpark? Drawback with the current databases. Advantages of Hadoop and PySpark. So I am supposed to discuss about this PySpark, right? Yes, I give introduction to this Hadoop. So in the yesterday session, right? Yes, just I'll give overview of what we have discussed. So everywhere we see like huge data is getting generated, like Facebook. Please click on next list. Yes, yes, 1 second. Wherever we see like Facebook, Twitter, Google, YouTube videos, upload, email, bank transactions, telecom transactions, right? Everywhere, everywhere we see like huge transactions, right? Yes. Like bank transactions, telecom, e-commerce transactions, right? Yes. If we just to take 1 minute transaction, if I just to take 1 minute transaction, that huge data is getting generated. So we see like day by day, huge data is getting generated. To store that huge data and to process that huge data, we need to have some proper storage systems and processing systems. Currently, we have got databases and specialized databases. So specialized databases like Teradata, Netezza, Vertica, right, is used for data warehouse purpose like OLAP operations, right? So as a solution to all these storage level problems and processing level problems, right, we have got a framework called Hadoop. Hadoop is providing two things. Hadoop is providing two services. Hadoop is providing two services, that is for storage and processing. Yes, Hadoop is meant for two things, that is for meant for storage, meant for processing. But for storing, Hadoop doesn't use any database. Is going with a special kind of file system called as Hadoop distributed file system. And for processing, it is going with an execution model called as MapReduce. Currently going with Spark. Next. So Hadoop is meant for batch application. Hadoop is meant for Hadoop is for batch applications, not for online applications. There are two types of applications. There are two types of applications. First one, user interactive applications like online applications. Second is like batch applications. Online applications, secondly, right? Batch applications. Online applications, user interactive applications, right? User interactive applications. Here, user gives the input. Here, user gives the input. Example of online applications: booking a movie ticket, where user gives the input here, and making a online payment. And the batch applications, right? Yes. User non-interactive applications. User non-interactive applications. User non-interactive applications. Booking a movie ticket, making online payment, and here, if we come to this batch application, non-interactive applications, here user is nowhere required. Here user is not involved. Example, for example, railway ticketing PNR status. PNR status. Like today, like your status is 200. The status is 200. After by evening, this your status is 150. Tomorrow morning 800. Tomorrow evening it got confirmed, right? So it is happening in the background. Your user involvement is not required. Most of these banking application or financial applications are batch applications, and other examples like generating credit card statements, generating credit card statements for millions of customers, for millions of customers. So Hadoop is meant for batch. It is not for online applications, right? So why Hadoop doesn't use databases for storing its data? Drawbacks with the current databases. So limited storage in most of the databases, no parallel processing in most of the databases. If volume increases, speed decreases. Means if I say, see the total amount from sales one, which has got 10 records, total amount from sales two, which has got 10 lakh records, total amount from sales three, which has got 10 crore records. Total amount from sales two, which has got 10 lakh records, total amount from sales three, which has got 10 crore records. Observe carefully here, right? Which one, which query executes faster means the first query which has got 10 records, right? As compared with 1 lakh or 1 crore records. Query to query, if the volume is increasing, speed decreasing. Even if complexity increases, speed decreases. Complexity increasing, speed decreases, right? Total amount from sales one, 10 lakh records. Average amount from sales one. Standard deviation of amount from sales one. Average amount from sales one. Standard deviation of amount from sales one. So as which query executes faster means again the first query. This is a two-step process. It's a two-step process. First sum to be calculated, next average to be calculated. First sum has to be calculated, next average has to be calculated. Yes, standard deviation of amount from sales one. So here query to query, as the complexity increasing, speed decreases, right? Yes. Databases can handle only structured data. Databases can handle only structured data, right? It can handle only structured data. They cannot handle unstructured or semi-structured data, right? And before I go with, okay, these are the drawbacks with the current databases. Limited storage, no parallel processing, volume increases, speed decreases, complexity increases, speed decreases. Databases can handle only structured data. They cannot handle unstructured or semi-structured, right? Before I go with the Hadoop advantages, right? So you need to know something about this Hadoop architecture. Hadoop follows, Hadoop follows master slave architecture. It's going to follow master slave architecture. Hadoop follows master slave architecture. Hadoop is Hadoop is not for client server architecture. Client server architecture. It follows master slave architecture, right? Yes. Okay. Okay. So here it follows master slave architecture, single master, multiple slaves. Single master and multiple slaves. Single master. Okay. Single master, multiple slaves. S1, slave 1, slave 2, slave 3. F1 dot the form of files. Always data stored in the form of files. So here, if you have got each system capacity 1 TB, 1 TB. F1.txt file, assume it is 2 TB. Its data cannot fit into any of these slaves. So it will be divided into smaller parts. So we call it as blocks. We call it as blocks. Each one is going to be stored across that. Okay. So here, a 2 TB data cannot be accommodated by any of these, split into smaller parts and stored options. So here, two advantages. Data is distributed across multiple systems. Data is processed by multiple systems parallelly. Data is distributed and processed by multiple systems parallelly. So, yes. Okay. Now, two advantages I said. Data is distributed across multiple systems. Data is processed by multiple systems, parallel processing, right? So this entire thing we are going to call it as a cluster. Cluster, group of nodes connected in a network. Cluster, group of nodes connected in a network, right? See, we call here within this we have got this we call master node. These are called as slave nodes. Slave node. So data is stored by the slaves. Data is processed by the slaves. Data is stored by the slaves. Data is processed by the slaves. Okay. So what do you mean by a cluster? What do you mean by a cluster? Simple. Group of nodes. Group of nodes. CPUs connected in a network. Connected in a network. There are two types of nodes. There are two types of nodes. Master node. There are two types of nodes, master node and slave node. Master node responsibilities. Task assignment, task assignment, load balancing, balancing the load equally to all this. Load balancing, fault tolerance, task assignment, load balancing, fault tolerance, health monitoring. Slave node responsibilities. First one, storing the data and processing the data. What is that? Storing the data and secondly, right, processing the data. Yes. Slave node responsibility storing and processing the data. There are two types of nodes, master node and slave node, I said. Master node responsibilities, this one. Slave node responsibility, storing and processing data, right? Yes. Now, based on this, right? So later I'll be briefing you in what are the storage that is in the architecture in Hadoop architecture, storage architecture and processing architecture. I'll be briefing you much about this, but now Hadoop advantages. Hadoop advantages, right? Unlimited data storage because of horizontally unlimited storage. Unlimited data storage because of horizontally unlimited scalability. Horizontally unlimited scalability. Very high speed processing because of parallel processing. So here horizontally unlimited scalability means uh, observe, check this. For example, if you an organization, a small organization that it has got some n number of slaves, only assume 10 slaves it has got. It has got 10 slaves. It is running with 10 slaves. But slowly, like customers have increased, branches have increased, even data has increased, means you cannot go with same number of slaves. You need to increase the systems horizontally. Unlimited number of systems or slaves can be added. So if customers increased by 100 times, data increased by 1,000 times, you cannot go with the same number of slaves. Horizontally unlimited scalability. Horizontally unlimited number of slaves can be added. Right? Yes. Horizontally unlimited scalability. Very high speed processing because of parallel processing. Very high speed processing because of parallel processing. Because of parallel processing, right? Yes. Just observe this. Parallel processing and non-parallel processing. Parallel and non-parallel. For example, non-parallel. Difference between non-parallel and parallel. For example, one person preparing one item, taking 1 minute. The same one person preparing 10 items takes 10 minutes. The same one person preparing 100 items takes 100 minutes. But here, the case of parallel processing, one item, 1 minute, 10 items, 1 minute, 100 items also takes 1 minute. Okay. Because here 100 per 10 persons preparing 10 items taking 1 minute. Here 100 persons working parallelly preparing 100 items taking 1 minute. That is what, but here persons, but in our terminology it is systems. Okay. Very high speed processing because of parallel processing. can handle all varieties of data, structured, semi-structured, and unstructured data. Can handle all varieties, structured, semi-structured, and unstructured, right? And it's an open source, no licensing required. And commodity hardware can run on any hardware, right? Yes. Yahoo has conducted a test to check the speed of different databases by taking a table of 100 TB consisting of 1024 columns, task sorting based on 16 columns. Sorting based on 16 columns, right? Okay. Oracle has taken nearly 3.5 days to process this. MySQL has taken nearly 6 days. MySQL has taken nearly 6 days, right? Teradata has taken nearly 4.5 hours because Teradata is a specialized database used for data warehouse, but Netija has taken 3 hours. Finally, where Hadoop has taken just 4.2 minutes, where these have taken days of time, these have taken hours of time, these have taken minutes of time, just 1.4. Latest Hadoop version, they have taken just 1.4 minutes. This is what the processing speed of Hadoop as compared with the other things, right? Yes. Why? Okay, it is proven processing point of view. Hadoop is proven not only processing point of view, storage point of view, right? Why databases like Oracle? Why database like Oracle won't support unlimited storage? Won't support unlimited storage. Databases like Oracle won't support unlimited storage means, yeah, for databases also there is a limit on the number of databases, max limit. Databases and max limit. Number of slaves. Databases and max limit on the number of slaves. One by one for Oracle. Maximum limit on the number of slaves. 256, right? 256 nodes, CPUs. For MySQL, right? 54, 54 nodes. MySQL Express. MySQL Express you got, right? MySQL Express that's got nearly 256 nodes. And SQL Server, 256 nodes. Next, DB2, 256 nodes. Yes. Oracle, MySQL Express, SQL Server, DB2, right? 256. But we have got some specialized databases, so they can go up to 256. Even if Oracle going with 256, right? Means if all the nodes are filled, it cannot support data further. It cannot support data further. Next, Teradata. It's going with 512 nodes for storing its data. Mm. Even Netija, another specialized database, right, which is used for data warehouse, right? Like Netija also going with 512 nodes, 512 nodes, and this Vertica. So going with Vertica, right? It is also going with 512 nodes. But in the latest versions, right? But currently, Teradata going with 1024 nodes for storing its data, CPUs. And Netija also going with 1024 nodes for storing its data. Teradata and Netija both supporting 1024 nodes for storing its data. Yes. Yes, but none of these databases are specialized databases supporting unlimited data storage, but there is no limit. But there is no limit on the number of slaves. That Hadoop can have. But there is no limit on the number of slaves that Hadoop can have. It can go with unlimited number of slaves. That's why horizontally unlimited scalability. Unlimited number of slaves. Yahoo when first time implemented Hadoop. Yahoo when first time implemented Hadoop. Yahoo when first time implemented Hadoop went with Yahoo when first time implemented with went with 4,000 slaves. Sorry, 4,000 slaves for storing its data. For storing its data. Yahoo currently going with 12,000 nodes for storing its data. 12,000 nodes for storing its data. Facebook, when first time implemented Hadoop, Facebook, when first time implemented Hadoop, when first time implemented Hadoop went with 8,000 slaves. Facebook currently going with 42,000 slaves for storing its data. Yes. So Hadoop is proven storage point of view by unlimited data storage, processing point of view with unlimited data storage, right? Yes. So yes. Just discussing about some of PySpark. So discussing about some PySpark, right? Hadoop and PySpark both are as part of this course. I've got both PySpark. So I can say it is a open PySpark. What is PySpark? Why PySpark? Need for PySpark. I can say like a real life use case of PySpark. Okay. What is PySpark means? It is an open source distributed cluster computing framework introduced by Apache Software Foundation. So PySpark is a general engine for big data analysis, processing, and computations. Why PySpark? It is a Python API to use Spark. The Python API to use Spark. Right. It is an open source cluster computing system. It is used for big data solution. PySpark is lightning fast technology. PySpark is lightning fast technology that is designed for fast computation. PySpark is one of the demanding tool among the data engineers who work with the bigger data sets. It is used for running a distributed SQL, creating data pipelines, ingesting data into database, running ML algorithms, working with graphs or data streams, and many more. Need for PySpark, right? Okay. So large amount of data is getting generated, right? This huge data consists of hidden patterns, some market trends, customer preferences, right? So we need to extract some valuable information from this raw data. So we require some efficient tool to perform these types of operations on the big data, right? We have got various tools to perform these multiple tasks on this huge data set. But these tools are not appealing, right? It's not so appealing that it will require some scalable and flexible tools to crack this big data and gain some benefit from it. So combination of Python and Spark will be the best way or the efficient way for the world of big data. So Apache Software Foundation came up with a tool called PySpark. It's Python API for using Spark. Real life use cases of PySpark means is mostly used. PySpark is mostly used in the commercial sector, right? So in the commercial sector, mm, means Apache Spark real-time processing in banks and financial fields is used. Spark is used to retrieve the customer social media information. Yes, plays a significant role in fraud detection and widely used with the machine learning tasks, right? Yes. Healthcare. Healthcare. It is used to analyze the patient's records along with the previous medical reports, right? And also in the entertainment industry, one of the famous OTT platform like Netflix using PySpark for its real-time processing, and it processed nearly 450 billion events per day that streamed over server-side applications. And also like it is used in e-commerce websites like Flipkart, Amazon, all these they use Spark, Apache Spark. It's used for advertising purpose and also for kind of recommendations. It is going to perform some kind of recommendations and enhanced customer experiences and optimizes the overall performance. Real life use cases of PySpark. So that's what even in the tourism industry, right? Providing advice to millions of customers by comparing hundreds of tourism sites. You can see that course content, right? So in brief, in depth, we'll be discussing about all this, right? Just check with this. So starting with big data, Hadoop, need for Hadoop sources and types, challenges, advantages, HDFS, Hadoop distributed file system, features, metadata management, map reduce, map reduce architecture, processing demands, mapper phase, reducer phase, right? So scoop for import and export operations. Scoop is used for import or export operations. Importing data from databases to Hadoop and exporting data from Hadoop to database. And we can perform different types of operations while importing from databases to Hadoop. During this import, right, we can perform different types of operations. What like filtering the columns, filtering the rows, filtering columns, grouping, segregations, merging, vertical and horizontal merging, right? Yes, writing scoop jobs and yarn, yet another resource negotiator, S another resource negotiator, right? So how the processing is going to happen, what yarn architecture, I'm going to discuss yarn architecture and yarn components, what are the different yarn components. And also I'm going to discuss about NoSQL database. One NoSQL database I'm going to discuss as part of this course, different types of NoSQLs, and HBase is one of the NoSQL that I'm going to discuss. And also one streaming component like Kafka, I'm going to discuss Kafka architecture, Kafka components, and this processing, right? Hive, one of the important component of Hadoop, Hive. With just if you got knowledge on Hive, the jobs are available only on Hive components. It looks similar to SQL. We have got HQL, Hive query language, right? How we load data from local files, from HDFS files, internal tables, external tables, working with XML data, JSON data, working with unions, joins, inserting into local files, HDFS files, how UDF, user-defined functions, user defines aggregated functions, user-defined tabular functions, partition tables, non-partition tables, static partitioning, dynamic partitioning, multi-column partitioning, and also like bucketing in Hive, indexing in Hive. Yes. Hive examples, Hive and HBase integration, right? And coming to the PySpark. PySpark introduction, need for PySpark, PySpark RDD computation, persistence options, PySpark core computing, grouping, segregations, various actions and transformations, PySpark SQL data frames, PySpark creating a data frame, empty data frame, column select, collect, with column renamed, where filter, drop duplicates, group by map, flat map for each, fill null, fill, PySpark SQL functions, aggregate functions, window functions, data and timestamp functions, right? Okay. PySpark built-in functions. So various built-in functions of PySpark. When EXPR, lit, split, concat, substring, translate, overlay to date format, date if once between explode, collect list, create map, map keys, map values. So some average row rank, dense rank from 2JS1, right? PySpark external sources, working with SQL statements, Spark and Hive integration, Spark and MySQL integration, working with CSV, working with JSON transformations, narrow and wide transformations, adding of new rows, dropping of rows, handling nulls, joins, deployment modes, local mode, cluster mode, PySpark application, right? Yes. States and task drivers and executor, building Spark applications, deploying Spark applications to cluster and tuning, performance tuning, right? PySpark streaming concepts, integration with Kafka, right? And these things. And apart from PySpark machine learning library. Apart from this, for this PySpark, Python knowledge is required. Total Python core and advanced is going to be discussed. Python basics, Python operations, operators in Python, Python IDEs, Python flow control statements, looping statements, strings, collections in Python, lists in Python, Python tuples, Python sets, Python dictionary, functions in Python, modules in Python, right? Packages in Python, errors and exception handling, file handling, object-oriented programming concepts, regular expressions, database access, Python date and time, operating system module, OS module, advanced concepts like iterator, generator, closers, decorators, GUI programming, TK Inter, Excel workbook, data analytics, introduction to data science, Python pandas, Python NumPy module, Python matplotlib module in brief, right? So this matplotlib for plottings and visualizations, NumPy numerical Python, this pandas module, especially even if you got knowledge on these three modules, there are huge jobs available on this pandas, NumPy, and matplotlib modules, right? This libraries, right? Yes. So this is what I'm going to discuss as part of this. So yesterday I was briefing you about this, right? We have got a big data package available where you will be discussing on Hadoop, PySpark, Linux, Python, which includes these four components. So this Hadoop, PySpark, and Linux will be on only on Saturdays and Sundays, weekends, 12 weekends, 15,000 is the course fee for entire this, right? So timing as of now, we have taken it, but timing of this batch will be 7 p.m. to 9 p.m. in the evening. In the evening, Saturday, 7 p.m. and Sunday, right? Python Core and Advanced, right? Nearly like 50 sessions on this Python Core and Advanced. That will be separate, excluding this 12 weekends. It will be from Monday to Friday on weekdays, because in weekends, again, it will take lengthy, right? So Monday to Friday, you can attend any of the morning or evening batch of mine. I also take like Python sessions. So Monday means tomorrow at 9 p.m. IST, there is a batch going to start for Python. So people who have taken this big data package, anybody can attend this. Otherwise, if you want in the morning, coming Thursday at 8 a.m. in the morning IST timing, there is a batch going to start for it. And for this, okay. Any other queries you have got, anyone, right? Okay. When about the software, other things, everything I'll be briefing you. I'll be providing all those to your Google Drives. Clear notes will be provided, soft copy of this. You'll be getting that, you'll be getting this session videos of each and everything of all this, right? Each and every session video you are going to get that day itself. Means only you can play it, you cannot download it. And soft copy of the notes and assignments and tasks to work it. A WhatsApp group will be created, right, for technical discussions, or if you got any errors, and take the snap and post in the group, right? And previously asked interview questions and resumes, right? Yes. Fine. Okay, so we'll meet next Saturday, but next Saturday the link is going to change, right? So you are supposed to get enrolled. So you can see in the chart a big message given by this online team. So can you see that course content of this? And yesterday, if you have anybody have missed that session of yesterday, that video link is provided, demo video, right? And The course fee totally for all this is 15,000, right? So if you want with the Python, it's 15,000. Without Python, this is up to this, it's 12,000 for this. But with Python, it is 15,000, right? Yes. Yeah. Once you see that, once you got enrolled, don't forget to share the screenshot of your payment to that mail ID that is provided, right? DURGASOFT online training. Then only you'll be getting the link, right? So if I'm done with this, so I'll sign off for today. So meet you next Saturday. More discussion on this, right? Fine. Thank you all for your time. Thank you. Bye. Gaurav, any query you got? Prerequisites for PySpark, you need this Python, but first I'll be starting with Hadoop, right? By the time Hadoop gets completed, it will take more than 1 month. So by the time parallel, you will be attending Python sessions, right? This 1 month. So Python is the prerequisites and the basic SQL knowledge is the prerequisites. Basic SQL, basic Python, basic Linux. Linux anyhow I'm going to discuss whatever required, and Python also I'm discussing, right? Basic SQL is required. This is the prerequisites, right? Okay, fine. Okay. So I'm stopping here. We'll continue next Saturday. Thank you all.